Okay, today's lesson, 2.5.b, is how to solve a system of equations algebraically, and we are going to use the substitution method. Our objectives are to find the solution to a system of equations using the substitution method. We learned how to find a solution by graphing, and we also learned that there are different types of solution. In this first example here, there's only one solution where they intersect. In the second example, there are no solutions because our lines are parallel. And in the final example here, there's an infinite number of solutions because our lines are the same line. Okay, but now we're going to figure out how to find these solutions using algebra rather than visually using graphs. So let's first go over some background knowledge, some prerequisite knowledge in order to be able to use the method substitution. So in this example here, we have two equations. We have one where x equals 5, and we have another one, 2x plus 6y equals 28. If I told you that x equaled 5, you could take this 5 and you could substitute it in place of all your x's because that's what x equals. So if we were to do that, we could write the equation as 2, and then instead of x, we would substitute 5 plus 6y equals 28. And that is a very general definition of what we are going to be doing for substitution. We're just going to substitute the number in for the variable. So we would carry on and we would simplify. 5 times 2 is 10, plus 6y equals 28. And now we are going to solve our equation for y. So we would subtract 10 from each side. And 10 minus 10 goes away. And we would be left with 6y on this side equals 18. 28 minus 10. Divide both sides by 6. 6 divided by 6 is 1, or 1y. And 18 divided by 6 is 3. So between these two equations, we know that they intersect where x is 5 and y is 3. Okay, and that's one way to do it algebraically. And so, like I said, this is a very simple way to demonstrate what substitution is. So now we're going to make it a little more complex. And just to remind you that while we're going through these examples, if at any time you need to pause the video, if you want to try something yourself or you need to take notes, go ahead and do that. Okay, in our first example, here we have y equals x plus 2. Okay, so y equals this. It's not any different than when I said x equaled 5 in the last example. In this example, y equals x plus 2. And then we have our equation down here, 3x plus 5y equals 10. So we're going to do the same thing, and we're going to substitute x plus 2 everywhere, where we see a y, not an x. This one's y. Let's erase that. Okay, so we will, again, substitute x plus 2 anywhere that we see a y, because that is what y is equal to. Now let's go ahead and do that. So we would take our 3x plus 5, and I'm just rewriting my equation, but now I'm going to substitute x plus 2 in place of y, x plus 2, and that equals 10. Okay, I need to go ahead and solve for x, so I need to simplify this, which means I need to distribute the 5 into my parentheses first, and then I will need to combine like terms second. So I have my 3x still, and then I'm going to take 5 and multiply that by x to get 5x, 5 times 2 to get 10, and that equals 10. Okay, I'm ready to combine my like terms. My x's are on the same side. 3x plus 5x right here will give me 8x. Okay, in order to combine my constant terms, I'm going to need to move the 10 first to the other side. And I'm left with 8x on this side. 10 minus 10 is 0, so that's gone. Equals 10 minus 10 here is also 0. Okay, I just need to move the 8 over to the other side now, so I will divide both sides by 8. 8 divided by 8 is 1, or 1x. And 0 divided by 8 is just 0. So now I know my x-coordinate, where these two lines intercept, but I don't know my y-coordinate. So what I can do next is to pick either the first equation or the second equation, it doesn't matter which one, and I will substitute the 0 in for x. So here we have equation number 1, here we have equation number 2. So I'm still substituting, but now I know that x is 0. So let's go ahead and write that up here. Now I know that x is equal to 0. So I'm going to use this first equation here. So let's go ahead and write it here. Y equals x plus 2, just because it's simpler. And I'm going to substitute 0 in place of x. Okay, so let's go ahead and do that. We would get y is equal to 0 plus 2. So that just means y is equal to 2. And then always finish off by writing your answer as a coordinate pair. So these two lines will intersect where x is 0 and y is 2. All right, moving on to the next example. In this example, this is set up so that both of these are y equals. Okay, so y is equal to 2x plus 1 here, and y is equal to 4x minus 1 here. What we can do then is we can just take either one of these and substitute it in for y into the other one. So if I go ahead and take this top one, y equals this, I'm going to replace y then with 2x plus 1. So if I write that out, I have 2x plus 1, that is now my y, and that equals 4x minus 1. Okay, I'm going to go ahead and combine my like terms so that I can solve for x. So I will go ahead and move the 2x to the other side just to avoid getting a negative x. 2x minus 2x is 0. So I have 1 on this side. 4 minus 2 is 2x minus 1. My final step here to combine my like terms would be that I need to, add 1 to both sides to move that over. 1 plus 1 is 2, and 2 is equal to 2x. Now I can solve for x. So I will divide by 2, divide by 2. 2 divided by 2 is 1. 2 divided by 2 here is also 1, but it's 1x. So I know now that x is equal to 1. All right. So what I have here, we'll go ahead and write this, x is equal to 1. And again, I just need to pick either this first equation here or my second equation to substitute the 1 in place of x. I'll go ahead and pick the first equation again. So we have y equals 2x plus 1. And I will substitute this 1 here in place of x. And if we write what we have y is equal to 2, instead of x now we have 1 plus 1. So y is equal to 2 times 1 is 2 plus 1. And then finally y is equal to 3. So our final answer, these two lines will intersect where x equals 1 and y is equal to 3. Okay, and that's my intersection, that is my solution. That's the one place that the lines will equal each other. Let's move on to another example. All right, in this example we have 2y equals 3x minus 2, and then here's our bottom one where we have y is equal to something, and that would be 2x plus 1. So we know that we need to take what y is equal to and substitute it in for y here in this top equation. Okay, so if I go ahead and do that, I have 2. I'm going to substitute the 2x plus 1 in place of y. And that is equal to 3x minus 2. Now I need to distribute and combine my like terms. So I'm going to distribute the 2 into the parentheses. 2 times 2x is 4x. 2 times 1 is just 2. Now I've distributed and I will need to combine my like terms. So I'm going to move the 3x over by subtracting it. 4 minus 3 leaves me with just 1x. 3 minus 3 is 0 x's, and so that is equal to negative 2 on that side. Now I will go ahead and subtract 2 from both sides to move that over. And on this side I'm left with x is equal to, well, negative 2 plus a negative 2 gives us a negative 4. So now I know that x is equal to negative 4. I'm going to write that up here. And I need to pick an equation. This time I think I will go ahead and pick equation number 2 because it's set up so that y is already solved for. So when I plug in a negative 4 in here for x, I will know right away what the y is. So I'm going to go ahead and use this bottom equation. And I will substitute in the negative 4 here for x. And then let's write what we have. So we have y is equal to 2 times negative 4 plus 1. 2 times negative 4 is negative 8 plus 1. So y is equal to negative 7. Negative 8 plus 1 is negative 7. So our final answer, the intersection of these lines is at negative 4 comma negative 7. So where my lines cross, that is my intersection. All right, we're going to try one more example and make this one a little bit tougher. In this example, we have 2 equations, but we don't have any of these solved for a variable. We don't have an x equals, we don't have a y equals. So what we would need to do then, our first step would be to go ahead and do that. So we have equation 1 here, and we have equation 2. If I examine both these equations, it looks to me that the easiest one to do that to would be equation number 1 because x is by itself. If I look at equation number 2, not only would I have to move things over to the other side, I'm going to have to get rid of the coefficient in front of the variable. Whereas here, this x is by itself, it would be a very simple thing to solve for that. So I'm going to go ahead and rewrite equation number 1. So I've got x plus 2y equals 9. And I'm going to move this 2y to the other side. I'm going to solve for x. That would be the easiest thing to do. So my new equation number 1 is going to be x. 2 minus 2 is 0. So x is equal to 9 minus 2y. All right. So let's go ahead and write what we have. So we have a new equation number 1, which is x is equal to 9 minus 2y. Our old equation number 2 has not changed. This is still 3x plus 5y is equal to 20. Okay, but now we can see what we need to do. X is equal to 9 minus 2y, so I'm going to take that and I'm going to substitute that in for x in my other equation. And now this looks like the other examples. So writing that, I would have 3 times 9 minus 2y, that's what I substituted in for x, plus 5y equals 20. Okay, again, in order to solve for y, I first need to distribute the 3 into the parentheses. And then I would need to combine like terms. 3 times 9 is 27. 3 times negative 2 is negative 6y, plus 5y equals 20. Okay, I'm going to combine my like terms, so I can combine the negative 6y with the positive 5y, and that will get me a negative 1y. Now what I'm going to do is move the 27 to the other side so that I can combine my constant terms together. So I will subtract the 27 from both sides. 27 minus 27 is 0, so that's gone, and I am left with negative y is equal to negative 7. 20 minus 27 is negative 7. In order to isolate y, I need to move this negative over so I can multiply both sides by a negative 1, which leaves me with y equals 7. My final answer then, x, oh, I don't know x yet, so I don't have a final answer, sorry. We're almost there. We know that y is equal to 7, so we need to substitute that into an equation. So let's go ahead and substitute that into this first equation since it's already solved for x. So what I'm going to do, move some of this over so that we have some room. All right, and let's go ahead and write what we are going to use. So we have y is equal to 7. And I'm going to use this first equation, x equals 9 minus 2y, and it doesn't matter which equation you use. I'm just trying to find the most simplest equation to plug this into. So if y is equal to 7 and I want to solve for x, I'm choosing the equation that's already solved for x. That way I'll do less simplification. So I'm going to plug 7 in for y, and we're going to go ahead and solve that. So we get x is equal to 9 minus 2 times 7. X is then equal to 9 minus 14. And finally, x is equal to negative 5. Now I have my two variables that I need. X is negative 5 when y is 7. So that means that these two lines will cross at the coordinates negative 5, 7. And that concludes our lesson on how to solve a system of equations algebraically. And this method is the substitution method. And if you think about it, it's just like the name sounds. You substitute in for one variable the equation of the other. Our next lesson will be an introduction to how to solve a system of equations using the elimination method. So it's slightly different, but another method that works very well as well.